This is Mark. He suffers from cerebral palsy. And this is Rick. He has a serious spinal injury. But the both of them are learning to use computers here at the Elizabethtown Hospital and Rehabilitation Center in Pennsylvania. Mark and Rick are just two examples of how disabled people are benefiting from the computer revolution. We'll take a look at computers and the handicapped on today's Computer Chronicles.
The Computer Chronicles is brought to you in part by McGraw-Hill, publishers of Popular Computing, the magazine that gives readers an understanding of the technology and applications of microcomputers and software in office, home, and
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. Gary, you know, sometimes a computer can make the difference for a disabled person between a very limited existence and, in fact, a very full life. For example, suppose I were speech impaired or hearing impaired and wanted to make a phone call. Well, I've obviously got a problem. Yet with this little portable computer, I could take this and hook it up to a telephone, and the computer can actually speak for me.
Can you come and take me home?
Now, Gary, are there spin-offs from some of these computer applications that are originally designed for disabled people that in fact help all of us?
Well, Stuart, I think that goes both ways. The benefits are both directions. Take a device like this, for example. We're going to learn a lot more about speech recognition and synthesis. It will apply to other areas. And let's say take something like a Mars rover. The robotics and vision processing that goes on there will perhaps lead to something like a mechanical seeing eye dog.
Okay, we're going to meet several disabled people who use computers. We'll meet people who design computer applications for the disabled. And we're going to begin by taking a look at some specific examples of how computers are being used today to help disabled people.
The application of computer technology to the special needs of the disabled is paradoxical, at the same time helping to increase mobility, but in other ways reducing the need for some of that mobility. This wheelchair is an example of how hidden computers can help some people regain lost movement. Without a joystick or other physical attachment, it performs all the functions of a motorized wheelchair, and all the user needs to do is point his head in the direction that he wants to go. Two ultrasonic sensors mounted on the back of the chair reflect sound waves off the rider's head. Measuring the difference in the time it takes for the waves to return to each sensor indicates to the computer whether his head is pointing left, right, or straight ahead. Offering a different kind of assistance to mobility-impaired individuals is the standard desktop microcomputer. Neither hidden nor specialized in purpose, the micro's innate characteristics make it an extraordinary tool for the disabled. The problem of interface is solved with a simple aluminum key stick. With it, the user has total control of the keyboard. This PC owner has a degree in computers and education and uses his machine mainly for programming. But it is the computer's more routine talents, word processing, communications, online databases, that play a pivotal role in expanding and simplifying his daily life. A modem allows him to send and receive messages through a network of bulletin boards and to access an educational library through a specialized database called Plato. The user can run a search through Plato for articles on a variety of topics, obtain free software, and even contribute his own comments. The microcomputer has often been dubbed a tool that can increase our access and control over information. But to some users, an ordinary micro can mean the difference between reliance and self-reliance, between losing control and taking control.
Joining us now is Peggy Barker. Peggy is a rehabilitation engineer with the Children's Hospital at Stanford. And next to Peggy is Sue Simpson. Sue suffered a stroke almost 6 years ago, which led to almost complete paralysis and a loss of speech. But Sue will show us how computer technology has given her the ability to communicate. Gary?
Stuart, a recurring theme that's gone through the whole show is how we use microelectronics to really improve our daily lives. And I think the show today is an excellent example of how microelectronic devices are used to, say, give access to computers for physically disabled people and how computers are being used to help physically disabled overcome those disabilities. And Peggy has an alternate input device here that I'd like to find out about.
Right. This is a membrane keyboard, and it's plugged into a device. It's called an adaptive firmware card, and it'll allow us to use the Apple with alternate input devices. And in this case, we've stored whole words and phrases on this keyboard, well, in the adaptive firmware card, so that someone with limited physical ability could select choices off of this board and access commercially available software.
So you can change the vocabulary of this keyboard if you want to think of it that way.
That's right. You could use it for word processing or other applications. So in this case, we're using our severely disabled children.
So
now
if I
can
push
use
this button right here, like it says store, then this will go into your adaptive firmware box and then acts like that those characters have been typed at the keyboard.
That's right.
And so then you have to change the front end of that software package.
That's right.
Okay.
All right.
Good.
Okay, and Peggy, what kind of people would be helped by using this kind of device?
Typically, the people that I work with that use this are individuals that have cerebral palsy, and they have limited fine motor control, but good gross motor control, so that they can make selections from these keys. Typically, they might be able to access the keyboard if they have a key guard on it, where they can, weed in one figure at a time, but it's real slow. So with this, they can get, a whole word or a phrase with just one keystroke, and it's also a bigger target. We can change the size of the targets on this board, too.
This
We're not limited to that
also
size.
a real good way to, say, play an adventure game where one button would say north, south, pick up, drop.
Right,
so
that's a great application.
Yeah. Good.
Now, what about a client who doesn't even have that ability to press those buttons? How would that person use the input device?
Right. For instance, if someone were not able to use their hands at all, and quite a few of my clients have good head control. Sue will demonstrate that as well. But in this case, say someone's got good head control, they might be able to, make choices right off of this board using this head one. And it really doesn't take much activation. It just takes, good head control.
Okay, we're going to talk with Sue in just a minute, so I don't want Sue to forget that we're going to find out about the fascinating device she has. I want to ask you one more thing. You have this other device, which again I take it could be used for someone who essentially couldn't even move their head the way you just did before.
Right. For instance, an individual that has ALS, where they might be totally paralyzed and just have movement of their eye. They just might be able to do an eye blink. And this device is developed by Words Plus and manufactured by Words Plus, and it'll allow me to with a blink of my eye, typically this would be sitting on a frame of glasses, you wouldn't be holding it in your hand, but with the blink of your eye you could make a switch closure, which would be the same as making a switch closure on a tread switch. In this case I'm using the control evaluator and training kit that we developed at Children's Hospital. And this device is used to make quantitative measurements of how someone uses a switch. So if I were considering using this eye blink switch with someone, I would evaluate them using this device. And a test that I can do would be a reaction time test, where coming onto this display will be a light, and I'll also get auditory feedback. And then by closing my eyes, I turned it off.
So this lets you discover what kind of device is the best kind of input for a particular individual then.
That's right.
Okay.
Okay, Sue, now I want to turn to you. And Sue, before I ask you some questions, I wonder if, Peggy, if you could explain the communications device that Sue's about to use.
Right. Sue is using an Express 3 from Prenke Romick. And with the Express 3, she will communicate with you either using a display, or she can type out a message on a printer, or she has speech output as well. And she can select her messages with her long-range light pen and make selections on this LED display.
Okay, Sue, now, first of all, I want to ask you to describe the machine to me in your words, and I think you've pre-stored that message, and describe it. Okay, this will be in only the visual readout mode, correct? So right. I'll read it since we won't hear a synthesizer. It says the memory storage is like a hotel with 128 floors and 100 rooms on each floor. I have almost unlimited storage. Okay, now that's a message you had put in there before, Sue. Now let's talk in real time. Suppose I just want to ask you what your name is.
My name is Sue.
So we can get the visual readout, and you can actually use the voice synthesizer to speak to someone. Peggy, how complicated is it was it for Sue to learn how to use that device?
Well, the hardest part was developing the head control. And when we first started using it, we used a light beam alongside that pointer so she could always tell where she was pointing. But she picked it up fairly rapidly. But most clients don't pick it up as quickly as she does. She's incredibly determined.
Well, I noticed that when Sue and I were talking before the show, she mentioned that for several years she did not have a device like this. And as soon as she got it, it just opened the whole world of communication to her. I think it's a wonderful application, obviously, of the microelectronics.
And essentially, Sue, you are really operating a computer through the device on your head, which you are pointing to those LEDs. I understand you're pretty fast at this, actually. How fast can you speak using that device? Also, Peggy, while we're reading it, Sue simply has to point in the right direction,
right.
And there's no enter key or anything.
No, it's just a matter of holding that position for a certain amount of time.
So it's a little bit like learning to type on a typewriter, I guess, just a different
right,
mode
right.
of operation. Mm-hmm.
Okay, so Sue is saying I can't adjust the speech speed, but of course you can speak pretty quickly by your ability to move the pointer around.
I noticed, Sue, also that you have certain words that seem to come out very quickly, so you're storing those also, like computer. This happens to be the one that just
one
came out
key.
immediately.
Right.
So
It's
you have
kind
a
of like the word
vocabulary.
we just saw.
So you have a little vocabulary of words that are built up as you move along. Mm-hmm.
Yeah, the English language is about 500 words that you commonly use, and the rest of them you have to are unusual. Yeah.
And Sue is telling us that she has pre-programmed these function keys on her own, basically.
Mm-hmm. That's right.
Okay, Sue and Peggy, thank you very, very much. These are fascinating demonstrations of the technology Gary was talking about. In just a minute, we're going to take a look at a Kurzweil machine. You can put printed text into it, and it will read it out loud. So stay with us to take a look at that. With me now is Sue Melrose. Sue is an evaluator of computer devices for a blind rehabilitation center at a VA in Palo Alto. Sue, we're talking about computer technology and helping the disabled. What did you have to do to read or do research before you had a machine like this?
Primarily when I did research, I would hire a person to read it to me or onto tape. The advantage of tape, of course, is that I'm not restricted to their schedules. But that's slow, and of course even listening to a tape, it takes almost as much time as reading because compressed speech is new.
Now, before we actually demonstrate the Kurzweil, tell me how this works.
This is primarily a reading machine, and that is, it looks very much like a copy machine. You lay the printed page down on top of it, the camera underneath the printed page then looks at it, scans it line by line, and after it's seen, each line will then output it in voice.
Okay, here's a sample page from a book that I'll put in the Kurzweil machine, and we'll see how it reads that page. And in just a second, Sue, you can go.
Okay, I'm going to use the control panel here. These controls allow me to move the camera around, have it reread something in its memory. If I didn't understand it the first time, it'll spell the word, read punctuation. I have a lot of different controls I can ask of it.
Now, this has a little bit of artificial intelligence built into it.
Practice sheet 5. Selections from Fabulous Tales and Mythical Beasts by Woody Allen.
Yes, in fact, I can. It will actually start reading the first few lines, not always correctly. And part of the reason for that is the first few lines it's taking to actually analyze the data. So that, for example, if it sees a letter it thinks is an A, it will start calling it an A, but if it isn't following the rules that an A follows, then it has to reanalyze it, maybe say that it's a G with the tail missing or something. So basically, if it makes a wrong decision, I can hit the Learning Forgotten button, and I can actually have it start reanalyzing again.
Okay, so now in addition to having just sent the output to the speaker, you've also loaded that file onto the computer.
Right. A very common use of this device now, but by blind people, is to get materials into Braille, for example. So they dump it into a computer and use a word processor such as I'm using now. I'm using Braille Edit, which is a standard word processor, but it has voice output and Braille output and input so that the blind can have access to it. I would then just simply read through this material and edit it for any errors that the computer or the Kurzweil might have made when reading it into the computer, And once I've corrected it, I would actually then put it out in output in Braille, sending it out to either a hard copy Braille or a Braille terminal such as the Versa Braille so that I could read it. For example, I find that voice is very good for sitting back and reading a document, making sure the sentence syntax is correct. But when I get down to spelling errors and punctuation errors, I need to read it myself. I also use it for outputting computer manuals so that I have the documentation I need to do the evaluations.
Okay, thank you very much, Sue. That's very impressive. We'll be talking some more in just a moment. The Kurzweil machine is just one example of a computer device that assists the disabled. Now we're going to take a look at a new device that is right out there on the cutting edge. Wendy Woods has a report.
Shoulder.
This robot began life serving as an arc welder on an assembly line. Today, it's serving the handicapped in a pioneering project by the Veterans Administration Medical Center in Palo Alto. Bob Yee is one of 125 disabled people trying it out. The robot responds to dozens of voice commands and can do just about anything a human hand and arm can do, from playing chess to picking up a water glass. Driven by a Zilog Z80-based microcomputer and a voice synthesizer, this robot is a prototype of things to come.
The sorts of things that we look at are the kinds of generalized technology, general purpose tools that not just a person with disabilities would want to have to help them, but you and I might want to have in our homes to help us. The more of us that want it, the more of us that will buy equipment like this, the sooner it will get to the people that we're really working to design it for.
I now have to have people feed me and do all sorts of things for me. Whereas if I had a device such as this, it would give me a lot more independence from other people.
That dream of independence may soon become a reality. At least 3 companies are closely watching the hospital's progress in robotics, with plans to mass-produce robots like this very soon. Meanwhile, designers here hope to have the robot on wheels by May. Its new life as a helping hand just beginning.
Bye-bye.
Bye-bye, are you sure?
Yes.
Yes, see you later.
For the Computer Chronicles, I'm Wendy Woods.
Joining us now is Noel Runyon. Noel is a developer of computer products for the visually impaired, and in fact, Noel was the co-inventor of IBM's talking typewriter. Gary?
I guess this is a question for Noel and Sue. I remember, I guess it must have been over 10 years ago, a project that I heard about. It was a vision substitution project where a camera was used and a tactile field device on a person's back would be used to sense what was on the camera. I was very intrigued by that, and I was wondering if there's where that project was and what's happened with that kind of vision substitution.
Well, there are a couple of different projects like that. There are some, such as the work with Linville at Stanford, that grew into a project that made a reading machine for reading print that you could read with your finger, a large tactile vibrating image on your finger. The larger systems that go on the back or large areas of the body are in an attempt to make something that would allow you to recognize a telephone or use an immobility. Most of those systems are still in their primitive research phases, and we're not expecting anything very soon from
this
those.
particular project, Sue?
Yes, it was done at Smith's Kettlewell Institute. And for example, I tried it once, and in a half an hour I could learn to tell a teapot from a teddy bear. So as you can see, it's very primitive and not real practical. They had some hopes that they'd be able to use it on an assembly line where they had very identifiable objects coming down the line to identify what's going by. But to this point, it's still, vision substitution it's something of the future.
Now, what about other devices besides cameras? There's and sonar, things of that sort.
There are some mobility aids that use sonar feedback, and you can get textural cues and how far away it is, and also whether it's to your right or left so that you can zoom in on it. But again, you're not knowing what the object is, you're just getting those 3 dimensions.
So do you think this is an area that needs further work and will bear fruit at some time, or just
It needs a lot more work, and yes, I think it'll bear fruit. But not only is the technology needing to be developed, but also we need to know what is it that a blind person needs to learn to be able to interpret the signals, even if they were given to you. You know, things like dimensionality and things that a lot of blind people would have to learn how to interpret.
It needs to be the proper kind of information, because you can end up running into a wall because you're busy trying to interpret the machine from your electronic package. And you could have heard the wall coming up.
Noel, you've been working in the area of audio and assistance to visually impaired people. Perhaps you could demonstrate on the IBM what you have.
What we have is a product that we've been working on called the Talking Tablet, and it can be used with computers. It's basically taking all of the hardware power of an IBM PC and putting it in a small portable package. And the thing uses a special technology called touch-directed audio, and it has a tablet that, if you wanted to imagine it as being like a computer screen, wherever you touch on the tablet, you would hear the corresponding speech for that information that was on the screen spoken out. Mm-hmm. And that gives you the ability to dynamically control the speech, select what information from the screen you wanted to be spoken out. And we have here a sample of this speech, because we're using what's happening now in terms of very good quality computer speech, but that's coming down in price very substantially, much the way printers is done. And we have various different things that you could type in here and get out, such as stored phrases, but we could also...
Now is the time for all good computers to come to the aid of the user.
Now is the time for all good computers to come to the aid of the users. I'll repeat that once.
Now is the time for all good computers to come to the aid of the user.
So you're basically getting your feedback instead of from the CRT in an audio mode, but you're entering data through the regular keyboard.
Yes.
I guess that sums it up pretty quickly, doesn't it? Okay, thank you very much for being here with us. Now, spreadsheets and adventure games and word processors, that's all very nice from computers. It helps us do some things a little bit better than we could otherwise do them before. But the kinds of applications we've been talking about on this program enable some people to do things they simply couldn't do without computer technology. Commentator Paul Schindler has some thoughts on that.
You know, I can either do this expense account on paper or on a personal computer. Same thing goes for a story for my magazine. I can either do it on the computer or on this trusty portable typewriter. In fact, almost everything being done on a computer today was once done manually, and sometimes it was faster and more efficient that way. But today we're talking about computers and the disabled. At last, an area where computers do things that simply could not be done before. Now, one simple example is online conferences. Sometimes the disabled have trouble participating in meetings. With a computer conference, their speech or motion difficulties vanish. Their participation is equal to that of everyone else. Computers also serve as a job equalizer, allowing the disabled to work. That opens opportunity for 36 million disabled Americans who, as a group, have the best attendance records. So, if you hire people, hire the disabled, give them a computer and watch them rip. Now, I know a lot of you are in the computer business, and I've got a few words for you. Get with it. Sure, half the computer devices used by the disabled cost nothing extra, but that last 8% cost as much as $2,000 more, and that's your fault. So get those prices down. That's my opinion. I'm Paul Schindler.
In the random access file, this was not a good week for computers. First of all, a big Internal Revenue Service computer fouled up and failed to process tax withholding payments from about 10,000 employers. Then another IRS computer automatically started sending out final notices to the employers, threatening to seize their assets. The error was eventually discovered after IRS clerks reconciled the thousands of records manually. The IRS says no assets were in fact seized. Then some hackers last week managed to get into a Sprint access code, giving them use of the Sprint long-distance lines. The hackers had used up about $5,000 worth of phone calls when Sprint caught on. But it then took 10 days to change the code. Meanwhile, the hackers were having a great time making 17,000 calls in the 10-day period. And the poor guy whose code they stole received a 722-page bill for $60,000. The good news was that Sprint gave him an $8,000 volume discount. And at the University of Southern California, some computer hackers got into USC's transcript computer, putting phony names on legitimate transcripts and instructing the computer to issue fake diplomas. A phony PhD was apparently going for about $25,000. But it wasn't all bad this week. The National Cancer Institute announced the country's first cancer treatment database. It will contain up-to-the-minute information on current clinical studies, treatments, and facilities with special cancer programs. Any doctor can access the cancer database from a personal computer. The National Cancer Institute says the new database will save precious days or weeks in developing the right treatment for a particular patient. Scientists at Stanford Center for Computer Research in Music have come up with a new computer that can listen to music and turn it into a written musical score. It takes about 5 minutes to score 1 minute's worth of music. Right now the system works best on Mozart. It's having a little trouble with Scott Joplin. Paul Schindler's up next with this week's software review.
What a spreadsheet! Maybe you don't need one that big. Maybe you think Lotus 123 Framework and Symphony are overkill. Maybe PFS Plan is the spreadsheet for you. Now, we're not talking giant spreadsheets here. In most PCs, PFS Plan could only do 64 columns by 176 rows, but think of what that means. 64 columns is 5 years worth of monthly data. 176 rows is 176 items per month. PFS Plan is the spreadsheet for the rest of us, not for the power users. It isn't big or sophisticated, it's just easy. Have a look at row identification. If you enter a name that's too long, the program adjusts. It allows you to duplicate figures quickly. If you start naming columns by month, it fills in the other months. Enter a quarter, it assumes you want quarters. Formulas in PFS Plan aren't as sophisticated as in the other spreadsheets, but they're a lot easier to enter. None of this add cell A3 to cell B2. In PFS Plan, profits equal revenue minus expenses in just those words. PFS Plan is the $140 easy spreadsheet from Personal Software in Mountain View, California. For Random Access, I'm Paul Schindler.
Engineers at the Campbell Soup Company in New Jersey have designed a robot to work in their food processing plant. But they forgot that everything in the food processing section has to be washed down every night for cleanliness. Well, robots don't take much to showers, so engineers are now designing raincoats for the robots to protect them from the daily dousings. Steve Wozniak, the co-founder of Apple Computers, reportedly is taking another step back from Apple to start his own company called My Best Friend. The Woz's new company is described as being in-home entertainment products, and with that name, you have to guess Woz will soon be selling personal robots. Finally, Apple has gone to great pains and expense to portray IBM users as conformist nerds. Yet last week, while Apple was showing off its Macintosh manufacturing plant, what should one journalist notice inside the Mac plant but an IBM robotic system putting together the Macs? Could there be lemmings in the orchard? That's it for this week's Computer Chronicles. We'll see you next time.
The Computer Chronicles was brought to you in part by McGraw-Hill, publishers of Popular Computing, the magazine that gives readers an understanding of the technology